Good morning to all. Today we will discuss set operations. Previous class we have already discussed about the fundamental of sets. What do you mean by set? How we can describe this set? What is subset, power set, proper subset, null set, etc. But now it is an important article for set, that is set operations. Set operation means union of sets, intersection of sets, set difference, complement of sets and symmetric difference of sets. All these. So first we shall discuss about the union of sets. Union of sets. Let A and B are any two sets. Let A and B are any two sets. Then union of A and B, union of A and B denoted as A union B. This symbol used for union we read as A union B. That is the set of all elements are in A or in B. The collection of elements which are in A or in B is known as the union of two sets. Union of two set is the maximum of two set. Maximum of A and B is their union. Maximum of two set is their union. And this is the Venn diagram for the union of sets. That is the maximum of two sets. That is known as A union B. A union B. A union B is the maximum of two sets. We can describe in set builder form as X such that X belongs to A or X belongs to B. This is the union. That is the representation of union in set builder form. For example, suppose set A contains element 1, 2, 3 and set B contains element 3, 4, 5, 6. Then we know that union is 1, 2, 3, 4, 5, 6. That is the union of two sets. Simple. Suppose set A X belongs to R such that 0 less than X less than 2. This is an infinite set because there are infinite number of real number between 0 and 2. And B set contains the element X belongs to R such that 1 less than X less than 4. A contains all the elements, all the real numbers between 0 and 2 and B contains all the real number between 1 and 4. Then obviously A union B equals to X belongs to R such that 0 less than X less than 4. That is the union of two set. If we represent in line 0, 1, 2, 3, 4. A contains the element 0 to 2 and B contains the element 1 to 4. Then union is 0 to 4. That is the maximum of two set. That is the example how we can find the union. These are two finite set, but here A and B are two infinite set. because there are infinite number of real numbers between 0 and 2. Here also there are infinite number of real numbers between 1 and 4. So their union is the real numbers from 0 to 4. This is all about union of two sets. If we take let A1, A2, dot dot AN are n sets. Let A1, A2, AN are n sets. Then their union denoted as union I from 1 to n ai, means A1 union A2 union dot dot n. We can represent union of n sets as by the symbol union I from 1 to n ai. Union I from 1 to n ai. That means A1 union A2 union dot dot union AN. We use the suffix here I, that is from 1 to n. If you use as I from 1 to 5 AI, then it will be A1 union A2 union A3 union A4 union A5. So we can represent union of n sets as by the symbol union I from 1 to n ai. These are the basic of the union of two sets, and basic properties are: properties 1, A union A equals to A. This is the idempotent law. Means union of a set with itself is the same set A. That is known as idempotent law. Idempotent law. Union of set A with itself is also set A. Number 2, A union phi equals to A. Number 3, A union B equals to B union A. That is known as commutative law. Commutative law. Commutative law. That is known as commutative law. Commutative law. Number 4, A union B union C equals to A union B union C. That is associative law. Associative law. Number 5, if A union B equals to phi, then A equals to phi, also B equals to phi. If the union of two set is phi, then both sets are phi. Number 6, if A union B equals to B, then obviously A is subset of B. Number 7, if A union B equals to A, then B is subset of A. That is the basic properties of the union of two sets. Union is commutative, union is also associative. That is the basic and fundamental properties of the union. Then we shall discuss about the intersection of two sets. This is all about the union of two sets. Next, intersection of two sets. Intersection of two sets. Intersection of sets. let A and B are any two sets. Let A and B are any two sets. Then intersection of A and B, then intersection of A and B denoted as A intersection B. This symbol used for the intersection. That is the minimum of two set. Union is the maximum of two set, but intersection is the minimum of two set, which is the collection of elements, collection of all elements, collection of all elements which are in A and also in B, which are in A also in B, which is the collection of all elements are both in A and B. That is the common element of A and B. Intersection is the common element of A and B. That is the common element of A and B. This is the A intersection B. That is the minimum of two set. Minimum of two set. Minimum of two set is their intersection. Minimum of two set is their intersection. A intersection B, that is X such that X belongs to A and X belongs to B. And we use the word and, that is the common elements of A and B. If A intersection B equals to phi, if the A intersection B is phi, means they are two disjoint set. They have no common element. A intersection B here phi, because A and B has no common elements. There is no common element. So if A intersection is phi, then A and B are said to be disjoint sets. Disjoint sets, or it is also known as mutually exclusive set. If the intersection of two set is phi, then they are said to be mutually exclusive or disjoint sets. They have no common elements. A and B have no common elements. In this case, we say that two sets are disjoint. For example, suppose set A contains element 1 and set B contains element bracket 1. Here A and B has no common elements. That's why we call it as disjoint set or mutually exclusive set, because they have no common element. Set A contains element 1, but set B contains element bracket 1. For that, they have no common element. In this case, we say that two sets are disjoint. If the set contains element A, X belongs to R such that 0 less than X less than 2. It is also an infinite set, not finite set. We cannot count the number here, because set X is a real number. All the real number between 0 to, there are infinite number of real number between 0 and 2. So this is a infinite set. And B contains the element X belongs to R such that 1 less than X less than 3. That is 0, 1, 2, 3. Set A contains the element from 0 to 2 and B contains the element from 1 to 3. Then the common element is from 1 to 2. That is the overlapping element which are both in A and also in B. So here A intersection B is the content element x belongs to R such that 1 less than x less than 2. If you draw the number lines, then you can easily find the union and intersection. For that clarification, you have to draw the number lines in which you can find the intersection and union easily. That is the common element of A and B. That is this all about the intersection of two sets. If intersection is 5, then they are said to be disjoint set. Suppose if A1, A2, A3 An are n sets. If A1, A2, A3 An are n sets, then their intersection denoted as intersection I from 1 to n ai. We can represent the intersection of n set as by this symbol intersection. We read it as intersection I from 1 to n ai. Here I is known as the suffix. I start from 1 and end in at n. That is intersection I from 1 to n ai. It is A1 intersection A2 intersection up to An. We can represent the intersection of n set by this symbol. Next properties, basic properties. First, A intersection A equals to A. Number 2, A intersection phi is phi. Number 3, A intersection B is same as B intersection A. That is the commutative properties. A intersection B intersection C equals to A intersection B intersection C. That is associative law. This is commutative law. In Odia it is called as Krama Vinimaya and this is known as Sahajogi Niyama. That is known as commutative and it is associative. Number 5, A intersection B equals to A means A is a subset of B. A intersection B equals to B means B is a subset of A. Because intersection is the minimum element and but union is the maximum. This is all about the intersection of sets. Next, we shall discuss about the difference of sets. Difference of sets. Difference of sets. Let A and B are any two sets. Let A and B are any two sets. Then A difference B. We read it as A difference B, not A minus B. Particularly set difference is written as A difference B. Then A difference B is the set of all elements are in A but not in B, which is the set of all elements are in A but not in B. That is the Venn diagram of A difference B. This is the Venn diagram of A difference B. That is the collection of all elements which are in A but not in B. Similarly, if we take B difference A, this part is known as A difference B and this part is B difference A. B difference B is the set of all elements which are in B but not in A. That is A difference B and that is B difference A. We can express in set builder form as x such that x belongs to A and x does not belongs to B. Collection of all elements which are in A but not in B. If we represent B difference A, that is x such that x belongs to B and x does not belongs to A. That is B difference A. A difference B and B difference A are two disjoint sets. They have no common element. A difference B and B difference are two disjoint sets. They have no common element. So, A difference B and B difference A are two different sets, are two disjoint sets. For example, if set A contains the element all real number 0 less than x less than 2 and B is the set all real number contain the element 1 less than x less than 3. This is also an infinite set and this is also an infinite set. We can represent this set as the open interval 0 2. Here it is also we represent as open interval 1 3. There are four sets. This is known as closed interval. Closed interval. This is known as open interval. Open interval. And these two sets are known as semi-closed and semi-open. Semi-closed or semi-open. These four intervals are used in our mathematics. That is known as closed interval and this is open interval. These two are known as semi-closed and semi-open. This means all the real number between A and B including A and B. The closed interval A B means x belongs to R such that A less than equal to x less than equal to B. That means all the real number between A and B including A and B. This is known as open interval AB. X belongs to R such that A less than x less than B means all the real number between A and B excluding A and B. We are not include here A and B. This is known as open interval and this is known as closed interval. That is semi-closed means here A less than equal to x less than B. That is known as semi-closed or semi-open. X belongs to R such that A less than x less than equal to B. This is known as also semi-closed or semi-open. There are four intervals. One is closed, second is open and next two are semi-closed or semi-open. These are also sets but these are all infinite sets. These are all infinite sets. Here A is all the real number between 0 and 2 and B is the real number between 1 and 3. We have to find the difference A difference B. We have to find the A difference B. How we can find A difference B? A difference means all the real number between all the real number in A but not in B. That is, if we draw the number lines 0, 1, 2, 3, A contains the real number from 0 to 2 and B contains the real number from 1 to 3. Then A difference B is the real number from 0 to 1. Means 0 less than x less than equal to 1. That is A difference B. Because 1 in A but 1 is not in B. So 1 is included in A difference B. Similarly, B difference A, x belongs to R such that 2 less than equal to x less than 3. That is B difference A. That is A difference B and this is B difference A. How we can find A difference B and B difference A? Next, fundamental properties. One is A difference B not equal to B difference A. Generally, set difference is not commutative. A difference phi equals to A. Number 3, A difference A equals to phi. Number 4, if A difference B equals to phi, then A subset B. If B difference A equals to phi, then B subset A. That is the basic properties of this set difference. This is all about the difference of two sets. Next, we shall discuss about the complement of sets. Complement of set. Complement of a set. Let U be an universal set. Let U be an universal set. In number system, set of real number is an universal set. Let U be a universal set. Let A be any subset of U. A be any subset of U. Then complement of A. Then complement of A denoted as A dash or A small c. That is the symbol for the complement of set. A dash or A upare C. That symbol denote for the complement. Which is the set of all elements are in U but not in A. Which is the set of all elements are in U but not in A. That is the complement of sets. If this set A and this is set U, then this part is denoted as the complement of this set. We denoted it as A dash. In set builder form, we express as X such that X does not belongs to A. Means if X belongs to A dash, that implies X does not belongs to A. That is the complement of set A. Means collection of all elements which are in universal set but not in the set A. If the set A is Q, means set of rational number, then its complement is Q dash, that is set of irrational numbers. That is we known as porimeo and that is aporimeo. If the set A is the collection of all rational numbers, then its complement is the set of irrational numbers. And the union of both set is the universal set, that is the set of real numbers. That is complement of sets. For example, suppose set A contains element all the real number 0 less than x less than 1. If we represent in number line, then all the real number from 0 to 1 are in set A. Then its complement contains all real number x less than equal to 0 union x greater than equal to 1. This is the complement of set A. Means all the real number except between 0 and 1. That is the complement of set. All the real numbers less than 0 and greater than 1. That is known as the complement of a set. Basic properties of the complement. First property is A union A dash equal to U. A dash whole dash equals to A, set A itself. Complement of universal set is phi set. Complement of phi set is U set. Complement of universal set is phi and complement of phi set is U. A intersection A dash equals to phi. If A equals to A dash, then U equals to phi. Universal set will become phi set. That is the basic properties. U difference A equals to A dash. U difference A dash equals to A. That is basic properties of the complement of set A. You have to remember this. Then you can solve some short question. You go through the textbook of mathematics by R.D. Sharma or by Sinha. Then you can find the objective questions which can solve by easy method and which will help for your preparation. First, your prescribed book is by council is Elements of Mathematics. Mathematics volume 1. That is your prescribed book by council. But there are some good books which you can refer. That is by R.D. Sharma, textbook of mathematics by R.D. Sharma for class XI. Also, K.C. Sinha is a very good books. Also for some textbooks which are also, that is higher secondary of mathematics, also by K.P. So you can refer any books for your better preparation. But your prescribed book is Elements of Mathematics. But you can refer one or two books for your clarification. Next, symmetry difference. Symmetric difference. Next class we will solve some problem on this article. First you prepare yourself and go through the theory and see the examples of books, textbooks thoroughly. In next class we shall discuss about the problem of the set theory. Set difference. Let A and B are any two sets. Then symmetric difference of A and B denoted as A delta B. That is the symbol for this symmetric difference. And this is the Venn diagram of the symmetry difference. That is the union of A difference B and B difference A. That is known as A delta B. That is the symmetry difference B, A symmetric difference B. But this symbol is used for A difference B and this is the symmetry difference B. These are two different things. This is called as the difference and this is called as symmetry difference. And we set builder form we represent as X such that X belongs to A difference B or X belongs to B difference A. It is also expressed as X such that X belongs to A or X belongs to B and X does not belongs to A intersection B. Means there is no common element between A and B. It is also written as X such that X belongs to A union B and X does not belongs to A intersection B. That is the representation of this symmetry difference in set builder form. That is the collection of all elements which are in A or in B but not in both. The collection of all elements which are in A or in B but not in both. That is the symmetric difference, A delta B. For example, suppose set A contains element 1, 2, 3, 4, 5 and B contains the element 3, 4, 1, 6, 7. Then A delta B is common element. There should be no common element. Then we have to 5, 2, 6, 7, or we can written as 2, 5, 6, 7, because 3 is in both sides, 4 is also in both sides, 1 is also in both sides. So this is the symmetric difference of A and B. Basic properties. First, A delta A equals to 5. A delta A equals to 5. Number 2, A delta 5 equals to A. Number 3, A delta B equals to B delta A, means symmetric difference is commutative but set difference is not commutative. Number 4, A delta B delta C equals to A delta B delta C. Symmetric difference is also associative but commutative associative, but difference of the set is not commutative, also not associative, but symmetric difference is commutative and associative. This all about the union, intersection, difference, complement and symmetric difference. Then next class we will go through problems on this chapter. Then we shall discuss about the cross product of sets, relation, functions. This all about your set operations. Now you go through your books and see the examples, what difficulties you face. In next class we shall discuss. Thank you again.